Assalamualaikum warahmatullahi wabarakatuh. First of all, I'm gonna say thank you very much for attending my final project to evaluation. Here's I'm gonna presentate about my progress this far about my final project. Here's my name. My name is Bagas Kurniawan. My student number or NRP is 4122 648. My first advisor is Mr. Eko Budi Utomo, and my second advisor is Mr. Himawan Sabdamurana. And my title is about prototype controller of timer and digital counter with industrial standard. So, what is the background? So, the background is first industrial pain point. Conventional counters that exist right now in the market are expensive, rigid, and require complex manual configuration which using crypt codes and buttons. So we need like manual book so we can configure it. Second point, the gap, a lack of affordable device that combine high precision with convenience usability. So uh we aim affordable device and convenience for configuration, which we using web and touch configuration here. So the solution is using ESP32 hardware PCNT for precision counting and its hardware timer for timing, Wi-Fi for modern UX, and bridging the gap between industrial robustness and digital use push of use. So what are the problems? First, how to implement high-speed pulse reading and timer using ESP32. Second, how to ensure seamless integration with industrial communication such as Modbus communication. Three, how to create a responsive web server for configuration, which we use for configuration the device, sorry. Four, how to create the product as cost-effective solution for SMEs, which cheap, affordable, mm, and we can trust its device to work properly anytime. So the objective first goal is to design an ESP32 based timer and high-speed counter capable of reading incremental rotary encoders. Goal number two, to integrate industrial standard protocols for interoperability for existing system in the industrial. And goal three, to develop a triple interface system, which is one, local HMI, wireless web server, and Modbus. And four, last, to provide a low-cost alternative for SMEs, or in Indonesia we say UMKM, compared to rigid industrial controllers. Scope and limitation. So what controls we use this time? It's ESP32 using DevKit-C module, or we can say it's built-in DevKit-C. What max resolution for encoder that we're going to use? It's not more than 4 million pulse per revolution. So what protocol communication that we use? So it can integrate with existing industrial communication. We use Modbus FTU. So this device can work as slave device, VI using RS 485 cable. What how many channels? I try to focus on two channel high speed counting, which is a mix. It can be counting or timer. We get two channel. So what environment we use for testing? We use lab scale for testing. So literature review. In the past, there's have been someone who used Modbus Ethernet uh, communication using ESP2 to monitoring electrical power consumption, temperature, and humidity. And there's someone in the past which have been implementing of ESP32 based web host for control and monitoring of robotic arm. If you can see in the image below. And the third, IoT based mini configure design using Ubiquitous platform using ESP32, which it it showed that ESP32 can be used as IoT device or what can you say web based like that, something like that. So, how is the research methodology? You can see here in the flowchart, we first start, we try to make a functional program for timers and counter, implement it in ESP32, then gonna validate it. After that, we try implement the Modbus RTU touchscreen at web server at ESP32. And the last, we make the product, we make the hardware, then we integrate all together. So first is the system design. Overall, the input is are gonna be 200 to 24 volt DC, which gonna be converted to 5 DC using a buck converter to supply of 5-volt sensors and 5-volt, what does it mean? Photoelectric and encoder as input. So the process, we use ESP32 as the main brain, main processor, and TTL to RS485 for to translate signal so it can be read by Modbus protocol. The output is Modbus, Modbus output, web server, and local TFT display. So also we got digital output. Software architecture, I'm planning to using non-blocking super loop with interrupt, so it doesn't make the program lags or something. Here's the main loop, as you can see. For now, I'm still using main loop because uh, I haven't finished yet the non-interrupting program, but the the counting is already using non-blocking program. So how handling overflow of the PNC? Because we know that PCNT in ESP32 only able to count at a 16-bit value. So if you can see here, if we if the counting is already reached the min or max limit, then there's a variable that can contain all the counting, something like that. So how the frequency measurement? This is for speed, the motor speed. We try to use to shift the motor speed using encoder. Here's the flowchart. And the design of the asynchronous web server design with not gonna delay the main program of the counting and timer. We use asynchronous web server design. It work in the background and tax burden for the CPU. And here's the implementation more Modbus RTU. We use device called AutoFlow Max 485 TTL to RS485 converter. Then on the table below, you can already see Modbus register that I have implemented. Here's my product specification. Input voltage is to 24 volt DC max frequency. I already tested using uh, signal generator up to 50 million hertz using PCNT. The communication we use RS485 Modbus RTU and Wi-Fi web server. The model for now still a timer, counter, and frequency meter. The feature we using hardware based for quadrature decoding, which is it can count forward or backward, and hardware based timer, so it doesn't tax heavy for the CPU of the ESP32. Here's the first testing. We use PSNT accuracy. You can see here up to 56 million count. It still have low low error percentage. You see here at the 56 million, it's having a bit a saturation of the error. So that's the limit. The second testing is the integration of the Modbus. Here you can see I'm using Modbus Pro software for testing it as a slave device. My final project, it's working. Here's the table. on the table below, and the software screenshot at the top. And the testing tree, integration of the web server and logic. As you can see here, web server is working. I can enable, disable, or reset high speed or timer. And on the table below, it shows that the program can detect whether the motor runs clockwise, counterclockwise, or stop. So the conclusion, Hexfit Pulse Rating implementation, I have successfully implemented using PSN2 to help units in double units counting mode. The result, the system achieved high precision with less than 1% error rate at frequency up to 50 million hertz, operating independently of the main CPU load. 2. The Modbus RT integration, seamless integration achieved using RS485 transceiver and Modbus Live configuration. Result, validated interoperability with master device using Modbus software, holding register. Yes, you can see the numbers. Successfully synchronize counter data and control logic in real time. 3. Asynchronous web server. I have successfully created a non-blocking interface using asynchronous web server combined with WebSocket protocol. The result, eliminate back refreshing, polling, the UI update with low latency less than 100 milliseconds, allowing smooth configuration via standard browsers. 4. Cost-effective engineering for SMEs. Engineered a double interface system, web and Modbus, running on a single low-cost ESP32 chip. Result, remove the need for expensive proprietary cables or software, offering a flexible smart node alternative to rigid industrial counters like the Autonic City series. Here's my final project one schedule. Here's my schedule for one project two. And here's the video. That's it. Here's the testing for proximity. This is the web service, web server. And here's my reference. That's all. Thank you for your attention. Uh, that's all from me. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.